So this is a video for F325 and it's basically showing how we can calculate the rate from a time concentration graph. So in front of me I've got the graph we used in the previous video to show how do we draw a tangent. Okay, we crossed both of the axes and we did it for initial rate, which is 0 seconds, time at 20 seconds, time at 40 seconds. So what we're going to do is calculate the rate at these three different time points, okay? Making sure that we include units as well. So hopefully at some point you'll cover the equation for rate, and rate is equal to the change in concentration of the reactants or products over the time change for the reaction to take place. Okay, so we're going to start off with initial rate because this is a very common one that comes up time and time again. So this here is our tangent for initial rate. Okay, mathematicians might be familiar with gradient equals dy by dx, but chemists, we use rate as change in concentration over time change, which is, it's the same principle basically. Either or is fine as long as you get the right result. So as long as we've covered both of the axes, we're fine. So why is our concentration change? Our concentration change for initial rate equals, so it's 0.2, take 0. It crosses the line at 0.2, and we've also got down here. So 0.2 take 0 is obviously just 0.2. Here, it crosses the x-axis at 18 seconds. So we've got 18 seconds take 0, which is obviously 18. So our initial rate, which is at time 0, I keep reiterating that, is just 0.2 divided by 18. And by my calculator, our initial rate is 0.011 recurring. Now units. Seconds is on the bottom, we've got moles per decimetre cubed at the top, so it's going to be moles per decimetre cubed, bring seconds up, so it's going to be seconds to the minus 1. Really important to include units. So our next one now, so time at 20 seconds. So again we do exactly the same. 20 seconds, where's our tangent for 20 seconds? It's here. So change in concentration over change in time we've got. So we're on roughly 0.1, about 0.13, take 0 over, got 30, 33 seconds take 0. So calculator, not take away, 0.13 divided by 33, that gives us 3.94 times 10 to the minus 3. Again, units. Mole per decimetre cubed to the seconds to minus 1. And last of all, 40 seconds. You have to excuse me, my writing is getting smaller and smaller. So 40 seconds, where is our tangent? It is here. So it crosses our x-axis at 55 seconds, so it's 55 takes 0. And it crosses our y-axis at around about 0.048. Make sure you double check your values when you're in an exam. So we've got 0.048 divided by, what did I write there? I can't read mode. Writing 55 seconds. So I've got 8.73 times 10 to the minus 4. Again, units. Moles per decimetre cubed seconds to the minus 1. So the key points from this video is, to get this, you need to have your tangent drawn, and your tangent has got to be crossing both of the axes. Using either your gradient equation, whichever one you can remember the best. I'm not bothered which one you use, the one you can remember the best. So rate equals change in concentration over change in time. To calculate initial rate, times 0, you've got to make sure your tangent is crossing the y-axis at time 0, and you do your tangent. Then you do change in y, which is 0.2 take 0, over change in x. And then in your answer, you make sure you put your units. Rate units are always moles per decimetre cubed second to the minus 1. Make sure you learn that off by heart, because you need to start using units in F325.